So this set of notes is what we're going to be doing tomorrow in class, even and odd functions. So we're just going to add the notes in today. So even and odd functions. Now, an even function is the following. We're going to talk about it graphically, and then we're going to talk about it mathematically. For a graph, so an even function's graph must be symmetric across the y-axis. So basically, if you were to fold the graph on the y-axis, it should be the same on both sides. The graph should be the same on both sides. So two examples that I'm going to draw is y equal x squared, a parabola, and y equal the absolute value of x. Okay, both of these would be examples of even functions. So let me just draw both of them. So if I was going to graph x squared, 0 squared is 0, 1 squared is 1, 2 squared is 1, 2, 3, 4, and so on. On the other side, negative 1 squared is 1, negative 2 squared is 4. And so we end up with this graph here. And again, if I was to fold on this line right here, it's going to be the same on both sides. Okay, it's the same on both sides. So this is going to be an even function. Okay, even function. If I'm doing y equal the square root of, the absolute value of x, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2, and so forth. So I'm really just going to be going up 1 over 1. Same on the other side, up 1 over 1. We had graphed these in our notes before. And then if I am going to draw this out, okay, we have that graph. And if I was to draw a line on this y-axis, you see it's the same on both sides. That, again, is an even function. Has to be the same on both sides. Okay. Now, what's happening in this is basically both positive x and negative x have the same value. So on this parabola here, when I went 1 squared, let me get a pointer here. Okay, when I went 1 squared is 1 and 2 squared is 4 on the other side, negative 1 squared also gave me a 1. So positive 1 and negative 1 both gave me a 1. Positive 2 gave me a 4, negative 2 gave me a 4. Same on this side. The positive 1 has the same y as the negative 1. The positive 2 for my x has the same output as my negative 2 does. Okay, so let me just jot down the following. both positive x and negative x have the same output. That's what's happening. So mathematically, we have the following, okay, for even functions. So for even functions, if I was to make my x opposite sign, it's the same as my positive x. So what I get when I put in a negative x is the same as I get when I put in a positive x. So how do I show this algebraically? So for example, if I was to take f of x is equal to x squared, okay, that is what f of x is. Now let me just do it in purple here. I'm going to do f of negative x, and I'm going to put a negative x in for x, and then I'm going to square it. Well, when I do that, a negative squared is still going to be a positive. So what you'll notice is when I had my positive f of x, I got x squared. When I had f of a negative x, I also got x squared. That means that it's an even. Okay, we got the same result. Got the same result. Now, an odd function, okay, an odd function, I'm going to add a page. Okay, I meant to add graph paper. Hold on, let me add a graph. So for an odd function, what's going to happen is the following. Let me just move this. For an odd graph, if you can rotate the graph 180 degrees at the origin, and it looks the same, it is an odd function. So, two examples of this. Y is equal to x cubed. Y is equal to x. So, let me just draw. Y is equal to x cubed. So I'm going to have 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Going the other way, negative 1 cubed is negative 1. Negative 2 cubed is 1, 2, 3, 4, 5, 6, 7, negative 8. And then if I graph it, there's my graph. Okay. Now, if I was to rotate this 180 degrees, you'll notice that in quadrant 1, it's going up, and in quadrant 3, it's going down. I'm going to come over here to the 3 bars. I'm going to rotate it clockwise once, clockwise twice, which basically did 180 degrees. And you see, I'm going to be getting the same graph. I still have it 1, 1. I still have it 2, 8. I still have it -1, -1. I still have it -2, -8. Okay. So that would be an odd function. So let me graph another one. So y equal x. So that would be a line 0, 0, 1, 1. I'm going to basically go up 1 over 1, up 1 over 1. Let me just plot this. So this is just basic y equal x. Okay. Now you'll notice that again, I have a 1, 1, 2, 2, 3, 3. Down here at -1, -1, -2, -2. Let me rotate it again. 180 degrees. And then when you're looking at it, again, this is upside down, but again, you still have it 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, -3, -3. It looks the same whether it's rotated 180 degrees or just not rotated at all. They look the same. That is an odd function. Okay. Now, what's going to happen mathematically? Okay. So mathematically, if I was to put in a negative x, just like I did for the other one, we always put in a negative x to decide if something's even or odd. What's going to happen is I'm going to get the opposite of f of x. That's what's going to happen, because here, for example, I have 1, 1, okay? But when I had put in a -1, I was at -1, okay? It was the opposite of my 1. So that's what has to happen. So let's say, for example, I'm taking f of x is equal to x cubed, and I'm going to put in a negative x. I'm going to see what happens. So if I put in a negative x and then I cube it, what happens is a negative times a negative times a negative is a negative. So I'm going to get a negative x cubed. So what happened here was I have this, and then when I put in a negative, I ended up with the opposite of it, okay? I ended up with opposite. So that means then odd. So let me just go through a couple of examples. So let's say, for example, we're trying to decide even, odd, or neither. Sometimes it's not going to be either one, okay? So let's say, for example, our first one is y equal x minus 3 squared. Here, let me do f of x equals x minus 3 squared. And so what I'm going to do is I'm going to put in a negative x. That's what we do. We put in a negative x. And so I'm going to have a negative x minus 3 squared. Okay. Now, looking at both of these, it's going to be a little hard to see maybe what's happening. So what I'm going to do in both cases is I'm actually going to multiply it out. So here, when I'm doing an x minus 3 squared, that is going to be, and if you need to, you can do a box, x minus 3, x minus 3, x squared, minus 3x, minus 3x, and a positive 9. So that's going to be x squared minus 6x plus 9. Now, this one here, when I have a negative x minus 3 squared, I am going to get, let me just draw that one out, a negative x minus 3, a negative x minus 3. So that gives me a positive x squared like the other one. This time I'm going to get a positive 3x though, and a positive 3x, and then a 9. So I'm going to get an x squared plus 6x plus 9. So I did not end up getting the same, okay? Let me just get a highlighter here, sorry. So here, this is what I got with the 1. Notice here, the difference is this is a plus 6x. So it's definitely not going to be even. Is it odd? Well, if it was odd, I should have ended up with the opposite. So let me say this. Not the same, not the same. Okay, did not get the same, okay, because of that plus here. Also, it's not opposite because the opposite of this, if I was to make this opposite, would have been a negative x squared plus 6x minus 9. So it's also not opposite. Also wasn't opposite. Okay, so when I put in a negative x, I did not get the same thing, which would have made it an even. I did not get the opposite, which would have made it odd. So in this case, this one is neither, and that's going to sometimes happen. So this is what we're going to be doing in class tomorrow.